Alright, let's go ahead and start doing some examples with curve sketching. So in this video and the next few videos we'll do some simple examples and then a few videos later we'll do some more complicated examples where the instructions basically just say sketch the graph of the function. So those are simple instructions but more complicated, more involved problems. But for now let's go ahead and look at ones like this. So example 1. Oh, by the way, if you want to copy this worksheet so you can follow along, check the video description. There's a link in there, so you can go there. You can click the link and open this, download it, print it, whatever you want to do. So anyway, example 1, the graphs of f, f primed, and f double primed are given below, and we want to determine which one of them is which. So 3 graphs here. We got this nice solid graph right here. We got a dashed graph up here. And then it might be hard to see in the video, but there's also a dotted line graph here, so a dotted graph here. It's not terribly hard to see on the worksheet if you print it out, but it might be hard to see on the video, so I'm going to trace over it here, just so it's a little bit easier to see and follow along. Okay, so now we want to know which of these is f, which of these is f primed, and which is f double primed. So let's call these something else. Let's call this g, we'll call this one h, and we'll call this one k. So why do we want to do that? Well, that's going to make it easier to talk about these once we start analyzing them, see how they relate to each other. Okay. So let's zoom out just a bit. Okay, so we want to use g, h, and k, for example, because one of these is f, but we don't know which one it is yet, so we can't use f. Okay, one of these is f, we just don't know which one it is yet, so we have to use other letters. So that's why we use g, h, and k. Okay, so to do problems like this, the key that you want to remember is that we've talked about it a few times before, and it's a very important concept to keep in mind. Remember, a function is increasing exactly when its derivative is positive. Okay, because remember, derivative is like slope, right? And if a function, or really derivative is slope, and if a function is increasing, we expect it to have a positive slope, so the derivative should be positive. And likewise, a function is decreasing exactly when its derivative is negative. Okay, so remember these, so we've used these facts a few times before in the past, we have talked about them. It's very important to keep those in mind. So a function is increasing exactly when its derivative is positive, and a function is decreasing exactly when its derivative is negative. Okay, so let's write that in a shorter way. So in a shorter way, we'll come up here. So a function f is increasing exactly when its derivative is positive. Okay. So this double-sided arrow here, that just means if and only if. So in other words, if f is increasing, then f primed is positive, and likewise, if f primed is positive, then f is increasing. So if and only if pretty much means that these two things on either side of the arrow here, they mean exactly the same thing. They say exactly the same thing. If you know one is true, if you know either one is true, then you know the other one's automatically true. So that's what this if and only if means here. So function is increasing if and only if, or exactly when its derivative is positive, and likewise function is decreasing if and only if, or exactly when its derivative is negative. Okay. So that relates f and f primed, but how do we get f double primed in the mix here? Well, you could talk about f and f double primed and concavity and things like that, but it's a little more than we need to use, and it might be kind of complicated anyway because these graphs aren't really labeled, so it's going to be hard to tell what the concavity is doing. For this particular example, it might not be too difficult. It's kind of tricky with g, but again, we don't really even want to think about that. So this function f and its derivative f primed relate to each other like this. Well, what about f primed and f double primed? Okay, f primed is a function, and its derivative is f double primed. Okay, so there's a relationship between f primed and f double primed that's exactly like this relationship between f and f primed. Okay, so the function f primed is increasing exactly when its derivative f double primed is positive. Okay. Likewise, the function f primed is decreasing exactly when its derivative f double primed is negative. Okay. So remember that a function is increasing exactly when its derivative is positive. So remember, the second derivative is the derivative of the first derivative. Okay, f double primed is the derivative of f primed. So f primed increases. Okay, this function increases when its derivative is positive. All right, so that's happening there. So that's really important to keep that in mind. So this set of facts right here, we do definitely want to keep those in mind. It's pretty much the whole key to doing problems like this. Just remember that a function is increasing when its derivative is positive, and it's decreasing. The function is decreasing when its derivative is negative. So that's really what you want to keep in mind here. So from here, what we want to do is pick any one of these and examine when is it positive, or sorry, when is it increasing, when is it decreasing, and see does that relate to positivity or negativity of any of the other functions. So let's take a look at g, and let's analyze g on separate pieces here. So when x is less than 0, what's g doing? Let's set aside some space here. So when x is less than 0, what's going on with g? So we want to see, is g increasing, decreasing, or anything like that? When x is less than 0, g is decreasing, right? It's decreasing this entire time. Okay, so when x is less than 0, g is decreasing that whole time. So when x is less than 0, g is decreasing. Okay, that's good. It's not quite useful yet, but we'll see if it can be useful later. So what about when x is positive? What's happening? When x is positive, what is g doing? When x is positive, that's to the right of the y-axis. And when x is positive, this whole time, g, remember g is this guy here, g is increasing this whole time, right? G is increasing that whole time. So when x is greater than 0, g is increasing. Okay, so that's great. Now what's happening when x equals 0? When x equals 0, what's going on with g? Well, see right here, that's the exact point when g turns around and changes from decreasing to increasing. And we've talked about things like that before, so what does that mean? That means there's a horizontal tangent line. And in this case, there is a critical point there, but that's not really the important point. The important point is that there's a horizontal tangent line. In other words, so if you have a horizontal tangent line at a point, what does that mean about the derivative at that point? That means the derivative is 0. Okay, so when x equals 0, g primed equals 0. Because g has a horizontal tangent line there when x is 0. Okay, so because of this horizontal tangent line, the derivative of g is 0. Okay, so when x equals 0, g primed is 0. Okay, so let's see, does that relate to, let's just pick h. So does that relate to h at all? So let's see, what's h doing on these same places here? So when x is negative, what's going on with h? Is it positive, is it negative, or anything like that? So what we've done, we're trying to use this kind of chart over here, and we've already found places when g is decreasing, g is increasing. So we found where g is decreasing, where it's increasing. So now let's see, is h positive and negative along those same places? So that's what we want to do here. So really just some trial and error here. And there are other ways to do this, but they might involve a little more work than you want to do. And the more practice you get with these, the less difficult it is, the more things might jump out at you. But anyway, for this first example, it's good to take it slow. So anyway, when x is negative, what is h doing? Is it positive? Is it negative? What's going on there? So when x is negative, that's to the left of the y-axis. And notice, h is decreasing and then increasing, but we don't care about that. We don't care about that at all, because we've already talked about decreasing, increasing, right, with g. So now we want to know, is something positive and negative along those same lines? And here we see that h is negative this entire time, right? H is below the x-axis this entire time that x is negative. So that's great. When x is negative, h is negative that whole time. Okay, that's wonderful. Okay, so what's happening when x is positive? When x is positive, so remember h is this guy here. When x is positive, that's to the right of the y-axis. H is above the x-axis the entire time. So in other words, h is positive. Okay, so when x is positive, h is positive. All right, what's happening at x equals 0? So for this example, we don't really have to go this far and point this out, but it does help drive the point home and make things a little more clear. So when x equals 0, what's h doing? Well, h, it's negative over here, positive over here, and then when x is 0, h is 0. H is exactly 0 because this graph of h goes through the origin there. Okay? So when x equals 0, h equals 0. Okay, so now let's piece all this together. So g is decreasing exactly when h is negative, right? G is decreasing exactly when h is negative, and that's when x is less than 0. Okay, so when x is less than 0, g is decreasing. When x is less than 0, h is negative. When x is greater than 0, g is increasing. When x is greater than 0, h is positive. Okay, so these two things are happening at exactly the same time. Okay, so in other words, g is decreasing exactly when h is negative. Okay, this function is decreasing exactly when this is negative, and this function is increasing exactly when this guy is positive. Okay? So if we go back up to our chart here, function increases exactly when its derivative is positive, function decreases exactly when its derivative is negative. Well, what's happening here? Function decreases exactly when its derivative is negative, a function increases exactly when its derivative is positive. Okay, so h is the derivative of g. Okay? And also this kind of helps drive that point home here. When x is 0, g primed is 0. Okay, remember that's from the tangent line. And when x is 0, h is 0. Okay, so g primed and h both have the same value at x equals 0. So we don't really need to point that out to establish that h is the derivative of g, but it does kind of help make that, to help solidify the point. But really, this is the main issue here. These two things together tell us, because of this chart up here that we made, that h is the derivative of g. Okay, so h is the derivative of g. So that means h equals g primed. Okay, h is the derivative of g. Okay, so we can go back up to our graph here and label this g primed. Okay. So again, that's happening because g is decreasing exactly when h is negative. Okay, and a function decreases exactly when its derivative is negative. And the function is increasing exactly when its derivative is positive. So that's why h is the derivative of g, because of these properties here. Okay, so now we got to figure out, all right, how does k relate to this? So, h is the derivative of g, so we already know that k can't also be the derivative of g, right? It's just not going to work like that. So one possibility is that the derivative of k is g, okay? So let's see what's happening here. So we'll do the same kind of thing here. We'll analyze that similarly. So let's see, that is one possibility. We'll see if that works out. So when x is less than 0, what's k doing? Well, remember, k is this dashed one right here, right? So k is increasing the entire time that x is less than 0, right? K increases that whole time, okay? So that's good. Okay, so when x is less than 0, k, excuse me, k is increasing. All right, that's great. What's happening when x is greater than 0? When x is greater than 0, that's to the right of the y-axis, k, this dash function here, is decreasing the entire time, right? K is decreasing. So when x is greater than 0, k is decreasing. All right, that's good. What's happening when x equals 0? Well, there's a horizontal tangent line there, but let's not worry about that. We don't really care about that. And why do we not care about that? Well, you'll see why in a sec. So let's see, does that relate to g being positive and negative at all? Well, when x is less than 0, k is increasing. What's going on with g at that same time? So let's come back down here. When x is negative, so here we have k increasing, so we want to see, is g positive, negative at the same time? Because we want to use this kind of thing here again. So we want to see, now that we've established when k is increasing and decreasing, we want to see, is g positive and negative correspondingly? So when x is less than 0, is g positive, or is it negative, or both? Or and yeah, here it looks like g is positive that entire time, right? Yeah, g is decreasing, but we don't care about that anymore. Okay, we don't care about that now. But g is positive the entire time. So that's good so far, because k is increasing exactly when g is positive. Okay, so far that's good. Now what about when x is greater than 0? K is decreasing, so we hope that g is negative, but is g negative? No, it's not. g is positive. Okay, g is sitting above the x-axis, which means g is positive. So when x is greater than 0, g is positive. So that's bad because this means that g is not the derivative of k. So even though over here we have k increases exactly when g is positive, but k decreases also when g is positive. Okay, so this really, this means that g is not the derivative of k, because when k decreases, its derivative has to be negative. Okay, its derivative has to be less than 0, but g is not less than 0, g is greater than 0, therefore g cannot be the derivative. Okay, so g is not the derivative of k. Okay. So g is not equal to the derivative of k. G is not k primed. Okay, so let's see. So I just want to point that out because, you might try to figure something out and you might end up with something like this, so just be careful because that could happen. But the only thing that tells you is that, this function is not the derivative of that first function there. So, that's okay. So now let's think of something else here. Well, maybe, what if k is the derivative of h? Or in other words, the second derivative of g. Okay, so let's see if k is the derivative of h. So this one's a little trickier because there's, we don't really have any numbers labeled. But basically what we want to see, so let's say, so maybe, let's say this, maybe k is the derivative of h, question mark, maybe k is the derivative of h. Okay, so when we did g and h here together like that, we wrote all these details out. So let's, first of all, we're running out of room, so let's not write too many more details. But also, let's talk about how to do this just by looking at it and analyzing it. So if we're going to assume, or let's just guess that k is the derivative of h. So we're going to guess, so let's guess that k is the derivative of h. Okay. Then what must be true? This must be true. So if k is the derivative of h, then that means that h increases exactly when k is positive. Okay, we're going to guess that k is the derivative of h. So h must increase exactly when its derivative k, we're guessing, is positive. And h must decrease exactly when its derivative k is negative. All right. So we have a lot of h's, k's, g's floating around. So I just want to, refresh our memory. So here, so we, one of these is f, one is f primed, another one is f double primed, and we don't know which one is which. So we just call these g, h, and k in the beginning, just so that it's easier to work with. Okay, so we're using these letters a lot. So you can imagine this would be very difficult to do if we didn't have these labels G, H, and K here. So that's the only reason we use G, H, and K. Really, we could call them anything except for F, F prime, F double prime, because we don't know which one is which yet. So just a quick refresher there. So this is the key here, though. Okay. So we're guessing that K is the derivative of H. And if we're going to guess that, then this has to be true. So let's see, well, is this true? Does H increase when K is positive? Does H decrease exactly when K is negative? Well, let's see. So here's H. Okay, H is decreasing. So let's see here. H decreases from here. Let's zoom in on this to make this easier to work with. Here's H. H decreases from here to here. Okay. Now when H decreases, we expect K to be negative because we're guessing that K is the derivative of H. Is that true? Well, here's K right here. And yes, K is negative that whole time. Okay, that's great. All right, now H is increasing from here all the way up to here before H turns around again. Okay, now that entire time, we have to zoom out just a bit. So that entire time that H is increasing, is K positive? Well, that's from here. Okay, so that started here. So the same X value is up here, okay, over here. And then we go back down to here, or over to here. Okay, so H increases from here all the way up to here. So we want to see, is K positive the entire time? So that means between this X value and this X value over here, is K positive? And yes, it is. Here's K between those two X values. and it's positive the entire time. Okay, so that's great. And lastly, h decreases again over here, and we're expecting that k is negative that whole time, and is it? Yeah, it is. Okay, so here's k. So h is decreasing when k is negative, okay, and over here h is decreasing when k is negative, and here h increases when k is positive. So yes, this is actually true. Okay, this is actually true right here. So yes, that is true. And that's awesome. So that means that our guess was correct. So our guess was correct. K equals h primed. But what is h? H is g primed, right? H is g primed. So this is really the derivative of g primed, which is just g double primed. Okay. Remember, k is h primed, but h is already g primed, so this is g prime primed, or in other words, g double primed. So this is g double primed. Okay, so which one is f, which is f prime, which is f double primed? Well, g prime, g double prime, so here's the function. Okay, this one's the function, this one's the derivative, and then this one's the second derivative. So here's the function f, okay, and this one, let's zoom out just a bit so we can see this. So hopefully your worksheet's not quite as messy as this one, but anyway, this one's the function f. This one right here is f primed. And then lastly, this one here is f double primed. So that's a nice coincidence. They all just go right in a row, f primed, f double primed. So anyway, and again, you know, we couldn't start with f primed, f double primed, because we didn't know which one was which, right? That was the whole point of this, is determining which is which. So that's why we had to start with g, h, and k. And it just so happened that, you know, derivative, function, derivative, second derivative, just by strange coincidence there. So anyway, that's how to do problems like this. So kind of a lengthy video, but really, once you get some practice with these don't really take that long. I just wanted to point out all the details here and talk about a couple different ways to think about it. So, you know, by writing out all the details, or just by, you know, looking at the graph and analyzing, okay, this one increases when this other one's positive, and so on and so forth. So a couple different ways to, or really the same way of thinking about it, but just, you know, depending on how many details you write, it really won't take that long, especially once you get the hang of it. So some more similar examples in the next few videos, and then more complicated examples after that for curve sketching.